Hello, everybody. So great to be here. My name is Robert Douglas, and I am here today to talk to you about the death and rebirth of childhood innocence in DevOps. But before we begin, for real, you need to learn about Rob's first law of coder dynamics. That says, whenever you're solving a problem, okay, and you're moving to a solution, the larger the distance between the solution and the problem on your logic path, if you're thinking step by step by step, from the original topic to the solution, the larger the distance you go, the more likely you are to download software that you don't need, okay? So for example, if I'm a programmer and I want to write an app that lets me scan automobiles and it looks up vintage automobiles and it looks up their make and model. Okay, great app. I scan the automobile and I get that's a Ford Model T or a Mercedes something. Then I might be thinking, image recognition, okay, boom. Training algorithms, boom. Python libraries, C bindings, static binaries, boom. All of a sudden, I'm out of the safety zone into the danger zone, and I'm downloading Call of Duty Black Ops 4, and it'll be a couple days before I start programming again, because the distance between the problem I'm trying to solve and the actual solution went out of the danger zone, and boom. Now, this is incidentally closely related to Rob's second law of coder dynamics, which states that for every second you spend waiting for a page to load, the likelihood of you spontaneously consuming 1,000 calories in the form of Coke and or Pringles increases by 1,000%. So those two laws are very fundamental to how we lose our childhood innocence in DevOps. So let's begin. Let's talk about developers. In the beginning, computers were toys. We played with them. Through playing, we learned to program. And through programmers, we felt an enormous sense of power. If we told the computer to do something, it obeyed us. It was like creating a new magical world all by yourself. And we imagined all of the programs we could build, the fantastic things we could do. And those became the goals that we had. We wanted to solve those problems with our computers, and we're very goal-oriented people. And with these computers, we learned to solve problems. We were children with toys, innocent children fascinated with the endless possibilities that our incredible toys would give us. And in our innocence, our childhood innocence, look what we've built. We've played without boundaries, and we've created a magnificent world. Everything around us that we enjoy now, it's full of apps and APIs and tools and cool things, enabling communication, enabling new possibilities around the world, and it's really created just an enormous amount of change. It's wonderful. But this is a story about how we have lost that child innocence, how it crashes, how it burns and falls apart, leaving us confused and unable to focus on the things that we want to build. In the beginning, deploying code was fun. You would subscribe to a magazine, which came every month in the mail, and you would open up the magazine, and there would be a nice program, and you would type that program in on your computer, and you would run that program, and you would learn lots of things, and it was really great. And in fact, since my computer had no physical storage, no disk drive, when I turned the computer off at night, the program vanished from RAM to be gone forever. And if I really, really, really wanted to run that program again, I had to type it in again. True story. Which means that every time I turned on the computer, it was a cost-benefit analysis about whether I wanted to spend that much time typing in the program or if it wasn't really worth it. And if I did type it in, it was usually because I had some ideas about how to hack the program, how to improve the program, and then I'd be very happy to type it in again. But if I didn't have that inspiration, then it wasn't worth it. And if you don't believe me, you can walk into the room right back there, open up this magazine, and you will see that even in 1986, this is exactly how programs were being distributed. And I had this magazine because I had a Commodore 64 and I had a subscription to that magazine in 1986. So it's very nice seeing these things over there. And then with my money that I saved, with Christmases and birthdays, I bought a disk drive. And then I could take my disk drive over to my friend's house, plug it into his computer where he had games, and I could copy the games onto disks. And I asked for floppy disks for Christmas. One year Santa Claus brought me 20 floppy disks. It was like 3 Christmases all at once. Blank floppy disks. Wonderful. And then I could run the programs that my friend had. It was a best dream for a child. And I learned to program BASIC. This is the complete list of commands in Commodore 64 BASIC. Great programming language. They were interpreted programs back then, mostly a lot of scripts. So this was BASIC, but Perl came and then later PHP and other scripting languages. And you just typed it in and you ran. And that's great for childhood innocence. You type it in and boom, it runs. The Python interpreters like that these days, just magic, full of childhood innocence. But along the way, scripting languages run into some limitations. And you move on to compiled languages, which have all sorts of benefits in the form of power, and they have bindings, and they have compilers, and they have IDEs that do syntax checks and libraries and stuff. That coincidentally is the moment at which we begin to trade some of the innocence that makes programming so fun for power, and the innocence begins to die a little bit. Just a little bit, just a little bit. It's not dead, but it's dying. Okay, this is the first drop of poison on our childhood innocence. Oh, and then fun things happened. They built these modems and we'd hook our computers up to networks. And then we had DSL and later 4G. And raise your hand if your first computer was a smartphone. Be honest, be honest. Okay, there's at least a couple of you out here. You're young, you're beautiful, you're innocent, and you have no idea what I'm talking about. Life is wonderful. Enjoy your innocence. The network let you skip the magazine subscription, the typing, and even the compiling, and then you could connect to other computers anywhere around the world and just copy programs and files. And the world seemed both endlessly large and endlessly small all at once. It was wonderful. And the cool kids were the ones who ran things like bulletin boards, places you could log onto and share things or chat or communicate with other people. And I actually know people who met on bulletin boards like this and got married. Internet dating in the 80s. Wonderful. So those were the cool kids running those bulletin boards, and then the internet happened, of course, and everything moved to the network, and we didn't store things on our own computers. We'd start to store things, you know, on internet servers, and as long as somebody knew how to find things, then you didn't have to have it locally. You could just go and find it and get it, and that's what we do all day long today. We Google for stuff, get it, and download it. And programming changed too. All of a sudden you could really benefit from the programs that other people had written, and you could incorporate them into your own programs. So, and this incidentally signifies a next important step in the death of childhood innocence, because that allowed us to have dependencies. And you got into a feeling where you could just download all the things. So I remember the first time I ran a Maven, I ran Maven install something, and it like downloaded jar files for 20 to 30 minutes. I was like, wow, that's great. So much software on my computer. But it's also a problem because dependencies can cause all sorts of problems. They can be broken. They can have bugs, they're maintained by other people, they can be spoofed, they can become unmaintained, they can have circular dependencies, they can have their own dependencies, and you can all of a sudden have a program that inadvertently depends on two different versions of the same library that try to occupy the same namespace, and another drop of poison right on top of the flower of childhood innocence. Blech. So, I'm going to emphasize this again, it's not totally relevant, but if you haven't been next door to this presentation, I absolutely love this because the history of computing is really fascinating, and to see this emphasized at this conference in this way was really nice. So just a call out to the conference organizers, brilliant touch. But let's come back to what our goal was at the beginning when we were programmers. Okay, what did we really want to do? What was the problem that we're trying to solve, the solution that we're trying to reach? Now, in my case, it's pretty easy. I just wanted to write games. I wanted to be Sid Meier and do the next Civilization. And if I had been a slightly smarter 10-year-old, then I might have actually done that because Sid Meier was my neighbor. And I could have met him when I was 10 years old. But well, you can't blame the 10-year-old for not being that smart, and we never did met, and I didn't become a games programmer. I did want to build all sorts of websites. For example, I had a whole business plan around news aggregators and adverts. And then I wanted to build a CMS for musicians because I have a music background and I thought that would be a great market to go in. It's a horrible market to go in. Selling software to musicians is a disaster. Don't do it. I wanted to build a learning management system because my mother was a teacher and I saw the software that she had to use and it was awful. So I wanted to help teachers around the world. And then I wanted to build a video rating site, right? Like that would never work. And then I wanted to build an app that recognized stolen violins, really. And I had some ideas for a specialized dating app. Those were all my goals. Well, I didn't do any of those, that's fine. But in each of the cases, when I tried to build one of those things, it went something like this. I'd have this interest in solving real-world problems, thinking about business cases, and that would be the center dot in my program. And in my innocence, I thought that it would be all about solving that problem and thinking about the functionality and the user journey and the business models. In reality, it was like, okay, I need a rating widget, NPM needs to be updated, the resulting new version of my XML parser dies on ingesting the manifest on the file system, which is not exactly in the right format, and I didn't even know I had that manifest there, and my two-factor authentication on GitHub just expired. Pringles. So, as soon as I would get so far away from the actual point that I was trying to solve, I gave up. My childhood innocence was damaged. I'm going to say at this point, with the dependencies and the complexity of programming, that weakened my childhood innocence. It didn't kill it. I wasn't ready to give up altogether, okay? The problem wasn't a crisis. I was more like Gandalf in Moria. I had enough energy to do the job, but I fell down a big hole. So that was part one about developers. Let's talk about sysadmins or operations people in the vocabulary of this conference, DevOps. So operations, okay? Ready, operations people? This is all about you. Remember the cool kids who could run their own servers? Isn't that amazing to run your own server? Let's call them operations. And their world has evolved too. They innocently started running servers under their desk, and then later in their garage, and then later in server data centers. And that enabled them to like have software that did things like allow them to communicate with other people without having to leave the house or even put on clothes or brush their teeth, which was great. And soon they started to lose their innocence too, because like that building one server, we all know building one server is really fun, okay? You get your operating system installed and you start putting in some programs, some packages, you're using apt-get or yum and you're like super enthusiastic and you've got some firewall IP tables stuff that you're doing and you're like hardening it, and you're like, man, my server rocks. And then you have to do that like 20 or 30 times while maintaining the first ones you built 3 years ago. Innocence, dying fast, not so much fun, especially since people will still ask you to fix their printer. They still will, no matter what. So, fortunately for all of us ops people out there, this happened. Virtualization, and everything became a cloud with lots of nines, and a lot of the complexity became abstracted and hidden, and we definitely had far fewer cables lying around, which was a good thing. So the servermen used to use things like VirtualBox, VMware, Vagrant, chroot, cPanel, Capistrano, Puppet, Chef, Ansible, and so forth. But then that all changed and new waves of tools came in, and maybe you used some of those, but maybe you used those along the way. Maybe you didn't, so things have changed over time. And by the way, this is the joke for the session, okay? Joke, how do you turn on your fan on your laptop from the command line? So again, how do you turn on the fan on your laptop from the command line? Anybody know the command? Docker up? Darn, you modernized my joke. I had Vagrant up. So there's the joke. Yeah, try that and the rocket ship takes off. So now you, as an operations person, you think about things like containers and container orchestration, and you hear more buzzwords and there's more complexity, and we've got conferences here where you're gonna, sessions here at the conference where you hear things like kubelets, pods, replication controllers, config maps, persistent volume claims, swarms, trust, okay? It's a great new world, and the operations people are like, yeah, wonderful stuff, and it's fun. And to keep up and to be able to work together, okay, the developers and the operations people, the developers are learning things like Docker Compose, and they're learning how to like prepare things that can go into that Kubernetes containerized orchestrated world. And it's a lot of learning, because in the end, we've got these operations people who are very good at creating huge complex systems that are necessary for running modern computing workloads in the cloud with all of the needs of scalability and security and compliance and DevOps that go into it. And at the same time, we also have application developers who are creating these very complicated, sometimes microservice, serverless, architected applications where just the level of complexity on either side of this equation is enough to make your brain melt, all right? And we end up with this. Thank you, Carlos. You end up with the wall of confusion source, Carlos, yesterday, where you've got the developers basically packaging thing into a box and tossing it over the wall of confusion to the operations, hoping that they can deploy it. And this thing, this purple box here, is so complex, and so much thought and effort and time went into packaging it. And the stuff that this guy over here is doing is so complex that they have a hard time even thinking about how to work each other. But they depend on each other. You need both of them to run any sensible web application these days. Which is why we have DevOps, which is why we're here at this conference. And DevOps is meant to help these poor developers and these poor operations people work together and maybe, if done really well, restore some of the child innocence that makes our work fun and meaningful. And as Carlos said yesterday, why should you, a DevOps person, be the one who fixes someone else's code running in production? Okay, you don't need to know about that. That's not your world. And neither is it the world of the developer to know about your pods. The developer's like, keep your pods to yourself. So we've got all this complexity, and it's a bit overwhelming. It's like the problem and the solution outside of the danger zone. This much complexity in our lives makes it so that we don't focus on the application logic, the business case, the user experience, and so forth. It's a crisis, okay? It's time for an intervention. It's time for somebody to come in and help things change. So that's what the DevOps person is for. This is us, the DevOps person. Poor developer, poor operations people, they need an intervention. So the new breed of DevOps tools for application developers are just a distraction on the logic path of the problem solving that you should be doing for application. And you know what happens when you get distracted from your goal. Jenkins, Ansible, Docker, Pringles. Okay? And guess what? That's not even the death of childhood innocence, all right? That just makes our life really hard. Let me tell you how childhood innocence dies. This is how childhood innocence dies. Equifax, in case you've not heard of it, is an American company worth 3.1 billion with 800 million individual customers whose personal data they store. Okay? They look at your ability to take credit, like a credit card, or sign up for a cell phone plan, or buy a house, or buy a car, or even get a job. And when you try to do one of those things, then the credit institution or the person selling you something or the person hiring you will call out to Equifax and say, hey, is this a trustworthy person? Should I do this service for that person? And Equifax will say yes or no, or maybe. So they're kind of important to those 800 million people whose data they store. And their brand is such a disaster these days that when you start to Google autocomplete on Equifax and you see, when you see that somebody's brand is associated with security breach 2017, stock dispute, and Canada, toast, you're dead, okay? Then you know for sure you're in deep shit. So I'm just going to look at a couple things that make Equifax really interesting. The first thing is the infamous CVE 2017-5638, and you're like, oh yes, CVE 2017-5638. That was a rough one. That was a rough one. That happens to be a 0-day remote execution bug in struts. Anybody familiar with that? Anybody hear of that? Yes, yes, sorry to hear you got hacked. Sorry to hear. Well, Equifax got hacked due to this. And they lost something like 140 million personal consumer data records, including credit cards, driver's license, social security numbers, addresses, everything that you would need to do identity theft on that person and do other damage with that. And of course, the CEO of Equifax did the right thing, and you all saw the leadership talk this morning, so you know exactly from the leadership what the right thing to do is when something goes wrong. You take responsibility. You say, it was the fault of a single developer that this happened. Poor developer. Okay? Now, it just so happens that this data breach cost the company $4 billion in market value. So, let's calculate what that one developer was worth to the company. And now, I know this is a hard sell talking about a TV show from 1974 that aired in America to Russians. But does anybody here know the $6 Million Man? Yes, 3 people. My joke is great. So this is the $6 Million Man. He has a bionic arm, meaning he got in an accident and they gave him a robotic arm and he was really strong. And in 1974, he was worth $6 million. That means with inflation, These days, he'd be worth $29,791,000. Compare that to the $4 billion mistake that this one poor developer made. Okay? And that poor guy, his only job on earth was to update some package, struts, on some server. And he didn't do it. It was the fault of that developer to not do it. Now, the poetic justice of the situation is that the CEO quit with a $90 million severance package and never had any problem at all in his life having overseen and being the leader for one of the biggest data security breaches in all of history. Okay, let's focus on the blame. Okay, who did it? Who did it? Was it Gary? Let's call Gary the developer. Gary the developer, was it really his fault that Equifax got hacked because of CVE 2017-5638? Okay, or was it Diane's fault? Diane's Gary's manager. She's the one who should have been, GDRP and all DevOps and Prince2 and had all the process in place for making sure that all of the security was good. Was it Diane's fault? Did she not manage Gary correctly? I'm going to say that it's more a problem of the way that they were thinking about software to begin with. They were not thinking about software the way that we need to think about software. And that is that software is a function of time. Over time, two things happen to software. One, you have to create new stuff and put it into the software. And two, you have to repair broken stuff. Okay? Now, creating new stuff is something that you can do whenever you want. Okay, maybe your manager says you have to do it today, but actually, in reality, you have the option of deploying your features whenever you want. Tomorrow's fine. Next week is also fine. A month from now, just also perfectly fine. But when something's broken, when you have a CVE 2017-5638 looking at you, you have to rebuild the entire server now. You have to deploy the entire stack. And if you're not equipped from a developer and operations point of view to do that within an hour, you will be Equifaxed. Okay? So that was just the beginning. The other fun thing about the Equifax story, which I'll throw in here just for your entertainment, is the brilliant and flawless response on the part of Equifax to this data breach. So first of all, when you have your data hacked and leaked and you're a consumer organization like that, you want to put up a website so that the consumers can come and find out if they've been hacked, if their data was stolen, because in fact, they're really worried about the personal damage that might be done to them. Do they have to cancel their credit cards? Do they have to call their bank? So of course Equifax made a site, which is hard to see, security.equifax.com. No, that would have been halfway competent. They didn't do that at all. They made a site, www.equifaxsecurity2017.com, which just by the mere nature of it got flagged by the DNS providers as a spoof site and blocked as a threat. Which is funny because at the same time, a white hat security researcher launched a site, Security Equifax, turned the words around, security.equifax2017.com, which was a genuine phishing site, except it didn't steal the data. It said, warning, this is what a phishing site should look like and you shouldn't do this. So he was a white hat security researcher. And Equifax tweeted that URL instead of their own URL, saying, please go to that site. So they did everything wrong. They set up a spoofing, something that looked like a phishing site. Then they tweeted out to the world, go use the actual phishing site. And of course they got called out in the news, and this is how they lost $4 billion of their market value. So is that Diane's fault or is that Gary's fault? No, that's about snowflakes. Things that you do one time only. Every snowflake is unique. And when you have your data hacked, there is no policy in your playbook for what to do, okay? Or maybe there is, but you probably don't rehearse it every day. It's a snowflake. There's no way in hell that a mature enterprise is going to have a procedure that's lightweight enough that you can put up a site in a day that says, have I been hacked, okay? Organizations don't work like that. The problem is they have to go to the operations team and fill out a form. for a subdomain on their domain, and the SSL certificate or TLS certificate that goes along with that, and then the servers, and set up a workflow and dev test stage and dev stage test, etc., to go into production with that website. And anytime you do that and you've got that much resistance and that much childhood innocence has to be broken to get the job done, people are just going to go around it. They're going to go around the whole system. They're going to go to GoDaddy and register Equifax2017.com and put up a WordPress site or something and say, whew, I did it one day. They're just going to power through. And when you power through with no procedure and your processes aren't agile enough to handle the situations that you're faced with, that's when you get Equifaxed. And when you get Equifaxed, that's the moment when childhood innocence dies. That's the moment where you've experienced the absolute horrifying death of everything that felt good about working with computers. No more play, no more discovery, no more wonder, no more lightness, only darkness. Every character you type when you code will feel like bitter hard work and suffering. So let's talk about the rebirth of childhood innocence and what DevOps can do for that. We've seen how childhood innocence of a developer or an operations person can die. Is that the end of the story? Are we destined to fight with overwhelming complexity, distracting us from focusing on our passions and our ideas? Will the bad guys always be able to break in and steal our data? No. And you know why? Because we're going to do what Gil Zellner said yesterday, and we're going to adopt a dev-centric position, okay? We're going to work as DevOps people to really make it so that the developers who would need to update a package and prevent CVE 2017-5638, or the people who are supposed to throw up a new website in response to an emergency, can do it with the lightness and the sense of discovery that you had when you typed in your first program. Okay? Now what follows are a set of guidelines and principles that come directly from me. They're only my own, and you can agree with them or disagree with them. I back them up with other sources where I can, and these slides will be available from the conference later if you want to look at them. But these are the list of guidelines that I'm here to give you on how to make a dev-centric position so that you don't get Equifaxed and so that you preserve your childhood innocence. Now, first of all, the one and only way to deploy code or applications is and should be git push or git merge. Okay? This should trigger the entire process, and it's not the same if you're SSHing into a server and saying git pull. Okay? The whole pipeline has to be triggered by the same thing that your developers do when they say, yes, my code is ready to commit. All right? And to back me up on that is Renee van Osnabrück, who says, make release management a functional practice instead of a technical one, from his talk yesterday. All right? Moving on, your system, which is code, applications, and services, has a build process. Embrace that fact and standardize it for every member of the team, all right? This comes back to the dependencies and compilation. We have to build lots of things before our application's ready, but lots of things look really different depending on whether you're building a Docker container, a Kubernetes pod, a Node.js program, or a C# program. It's roughly similar, but it's not the same. However, it can be standardized, all right? You can standardize the steps that go into a build process for every application, and you should. And building should always be triggered by git push, and it should be roughly the same for everybody, all right? It should go through phases like resolving dependencies, compiling, packaging, etc. And make it as standardized as you can for everybody who has anything to build, and you will benefit. Next, Always test against real data. And this is really hard because oftentimes we have lots of data. It doesn't have to be all of the data, but it has to be real data. Always keep in your mind the case of an e-commerce website that's about to do the winter collections of women's shoes. Let's say the summer collection. The summer collection of women's shoes is far better than the winter collection. Okay, so you've got beautiful shoes and they want to do a feature on the collection. You actually need the data. The pictures of the shoes, the names of the shoes, the prices of the shoes, all of their features, all of their facets in place before you can test from a marketing point of view anything having to do with that collection of shoes. So all of the development that the application developer needs to do at that point needs to have the real data in place. All right? You can use great technologies like Ceph, file system, which Red Hat owns, which now I guess IBM owns, to make copy on write copies of your production data with no cost to your production system to make data available to developers. And I saw very little talk about actual production data in any of the talks here. If you talked about it, I'm sorry I missed it, but to me this is a super important point. Developers of applications need real data. Applications are code, infrastructure, and data. And if you don't have all three of those, you've just got a broken, unholy mess that you can't really test. Next point, every single build you do should have a testable URL that you can send to stakeholders. Why? There are lots of things that go into this. It's not just automated testing. It's really about communication with your team and your stakeholders. When you do a build, you should be able to copy and paste a URL to somebody in Slack or Skype or chat or email and say, is this right? Is this what you had in mind? Am I on the right path? Am I on the right track? Now, if it takes a long time for that person to verify what you've done, as a developer, you're going to lose your context. Think about yourself typing a feature, recoding a feature, deploying a feature, all of the mental energy it takes to get into that, and you send it off to somebody who's a stakeholder. If you wait an hour and they come back with suggestions, you're still in the context. Not such a big context switch. If they wait till tomorrow, 1 cup of coffee and you're back into the context. If they wait till next week, you have to look at your notes and you have to try it out yourself again. If they wait a month to give you the feedback, then you're gonna be like, I wrote that? What? So make sure you make a build for everything you do and that you can test that with real user input right away. Who agrees? Mika Deenan agrees from yesterday. She says, create feedback loops to improve communication, involve stakeholders and management, and do that at every step of the process. Next, built code. After all the dependencies are resolved and the code's been compiled and everything, should be put onto a read-only file system. Always. Your operating system as well should be put onto a read-only file system. The only writable volumes in any application should be protected from program execution. Meaning if I have a, let's say, ASP.NET or PHP or Perl file in a writable directory, it should not be executable by any process on my system. Lots of applications violate this, but there are workarounds. All right? What are the reasons for that? Immutability. You should be able to link any Git hash to an actual built system. And if you redeploy that Git hash on any infrastructure anywhere around the world, you should always get exactly the same system every time. You should never be able to SSH in and say apt-get. No. Bad. All right, you should never be able to SSH in and change the code. Also bad. Now, as a result of this, read-only file systems lead to disposable containers. If you're running containerization of any sort, please be in the mindset that you build immutable containers, and when you want to change any small detail about those containers, please throw them away. Do not reuse them, don't change them, don't modify them, update them, or whatever to them. Throw them away, okay? Who agrees? René van Osnabrücke. He says, think immutable, build your infrastructures from code, and I agree wholeheartedly. The Git hash, the code that you have in your Git repository, should be enough to deploy the entire application every time, and it should link directly that Git hash to a built immutable infrastructure that you can redeploy anywhere at any time. Next, developers should have some, but not total, control over the services and the environment. Okay, for example, I agree that developers should be able to control runtime versions. You need to upgrade your Python version? Go right ahead, developer. You should just have to change one line in a YAML file or XML file or an environmental variable or something, and boom, you've got Python to the newest version. Configuration of services like Solar plugins or maybe the heap size of MySQL, who knows? Buffer, whatever. Yes, you need to be able to control that as an application developer because you have a lot of insight about how your application uses those backend services. Nginx redirects, rewrites, yes. Extensions, libraries, dependencies, yes. But there are a lot of things that you shouldn't be able to control as a developer, like the networking between services. That's not your domain, that's the operations domain, and the system should be just building that for you. Next, variables that change per environment should be injected into the running application. Okay, this goes along with possibly 2 slides away from me. I might repeat myself that sensitive data should not be put into Git, but it's worth repeating. So if I have the slide in 2 slides, I'll repeat myself. Variables that change per environment. What do I mean? We have production. Okay, you have a variable that, say, links your application to a payment gateway because you're an e-commerce website and you need a token, a secret token, to make payments on Stripe or PayPal or wherever. You also have development environments on your local laptop, on dev, stage, prod, and UAT and test and whatever you call it. They also need some sort of payment solution that connects to a sandbox to verify that you're using the APIs correctly and that you can actually do an e-commerce workflow and buy the shoes that are on sale for the summer collection. Those need to be different variables than the production, and the developer shouldn't have to worry about them. And the developer shouldn't put them into code. And who agrees with me? Patrick Baumgartner agrees with me. He says yesterday, if you're running your application in a Docker container, you want to configure that from the outside. Okay? That's the same as saying environmental variables should be injected, not stored in the code base. Oh, guess what? I repeat myself. I have a slide that says sensitive data, keys and tokens, should also be injected into the running application. Who agrees with me on that one? Benny from yesterday, who said, you don't want sensitive information in your configuration files. It's nice that we all agree on these points. All right. Next point, deploy and test every Git branch in isolation. So there are 2 key words here, every and isolation. You want to be able to test every Git branch. Every one that every developer on your entire team creates should be testable with real data and real infrastructure. And you want to be able to do it in isolation, meaning you don't want them all to connect to the same development database somewhere. No shared databases, no shared Solar servers, no. Rebuild the whole thing every time. It's worth it because the configuration or the actual operational details and data that might be in that database or that Solar might screw up your testing if it depends on different things like different collections of shoes in your e-commerce website. Next, deploy all applications and services in the same way. This goes back to Git push, Git merge being the only correct ways to deploy applications, period. Your Node.js app shouldn't have a fundamentally different deployment process than your Python app. And this includes things like, no, it's not okay to have to upload a zip file to Lambda to deploy. That's insane. Who thought of that, AWS? That's insane. Somebody needs to help them modernize that so that you can deploy all of your applications the same way. That's a great place for connectors and toolings to fill the gap. But if your deploy process involves uploading a zip file to Lambda, I don't like it. I would not want to be part of that deploy process. All right, And finally, make it easy, automatic, to practice database migrations and test them on every single deploy. Database migrations include schema updates, things like cache clearing, things like importing data, like if you have a product information management system, a PIM, or product catalog that needs to bring new shoes into the collection so you can test those shoes, test that on every deploy. Deployments should also be optimized for protecting data consistency. In some systems, this might come at the price of some downtime, hopefully not, but it's not okay to throw new code onto a file system if there are database changes that come along with that, because you'll have an inconsistent system. And at that point, protect your data consistency over your uptime and argue that if there's no other way to do it, it's better to have downtime than inconsistent data. However, there was a session yesterday about zero downtime database deploys, and you can reference that for at least 3 or 4 strategies which seemed really good for achieving that, except for one. I disagreed strongly and I heard it twice. I think that feature toggles are a hack. Don't do them unless there's no other way. Okay, so you heard all about feature toggles. I disagree with you other speakers. I disagree. I think they're the spawn of the devil. Okay. So if you do database migrations that take a longer time or that will lead to downtime, please reference the video or the session from Michael Rook yesterday. It was fantastic, and there were at least 4 to 5 different strategies that you can employ for avoiding downtime during a database migration. Finally, last point. If you have to do your own container orchestration, and there's a big if at the beginning of that sentence, a big if, you don't necessarily have to do your own container orchestration. But if you do, if you're in the position of bringing complexity into your system and owning that complexity because you like the control, use Kubernetes. Who agrees with me? Carlos Sanchez from today. He says we Cloud Bees, are betting on Kubernetes for everything. Kubernetes is the de facto standard now. I agree, my company agrees, and if you want to do your own container orchestration and bring that complexity into your organization instead of finding a way to get it out and have somebody else do it, Kubernetes is probably the way. Because saving childhood innocence then means removing complexity and distraction that stands between you and your programming goals. Saving child innocence means not going outside of your circle of concentration when following the idea thread and solving a problem. You have to find faster ways to get to your goal. One example that I know about how to do this allows you to do things as a developer like say, hey, I want PHP 7.2 and I need 5 gigabytes of disk space to do it, and these are the backend services that I've got, and please let my application know about them, and I need those hooks to run every time I deploy and build my stuff, and it brings the whole DevOps conversation down to the point of view of the developer. And when you can do that as a DevOps team and you succeed in being dev-centric in your positioning and your thinking, and the developer can simply say what they need, package it into their application, and go with git push or git merge, then you have a chance of restoring childhood innocence. Okay? And then you can live together in harmony, building wonderful applications, improving the world we live in, and enjoying your childhood innocence. So, I am grateful to the company that I work for, Platform SH, for supporting me being here today and for teaching me most of those concepts that I shared with you. And this includes a lot of nostalgia, this presentation from the 80s and the 90s. I grew up in the United States of America during the Cold War and had a different experience with computers than probably some of you out there had, especially people who might be my age. I would love to hear from you after the session what your experiences were with your childhood innocence computing as a Russian or somebody else anywhere in the world, and that would be really fascinating. So take the opportunity to talk to me after the presentation about that. And that's the end of my presentation. We can then move to questions if anybody has questions.
Can you explain your position about feature toggles? You said you disagree with
Feature toggles, yes, yes. So I believe that the code you want to deploy should only be the code that you actually want to run, not code that, there we go. Wow, that's weird. Hold on, I'm distracted by this. Let me get that right. And I think that's working correctly. Okay. Does that look right? Okay, good. Feature toggles. Code should express what your application should do. It shouldn't need to account for things like what environment you're on. There are other ways to do that. Okay? It also shouldn't account for eventualities that can be handled by the infrastructure and the operations. Okay, now there are feature toggles. The if statement has a place in code. If I'm dealing with somebody in Moscow, then I might want to show one thing versus if I'm dealing with somebody in Warsaw. Okay, so that's a feature toggle in a way. That's a logic path. I'm not saying if statements are bad in code, but I was hearing all sorts of advice about feature toggles that can say, is the application deployed properly? Is my data in the right consistent state? Is my infrastructure working the way it should be? And I don't think that's the application's responsibility. I think that is a drop of poison on the childhood innocence of the developer. And that if you put a feature toggle in there, it's unlikely that the product owner has been able to properly think about what that means to the user experience of the product. And you as a developer are unlikely to be able to track all of the long threads of influence that that decision will have, and you'll have unexpected consequences. And later, you'll have dead code that's not doing anything, or magically does something when nobody expected. Imagine stepping onto a feature toggle that you didn't even know was there, and you just don't know why your code is behaving that way, and somebody didn't remove their feature toggle, and you just called it the same thing. So depending on how you do your feature toggle, it's like setting landmines for future programmers, and you probably won't remove them if you can't deploy fast enough to be responsive to what's happening with your application, and you have to think ahead with all these feature toggles because you can't deploy on time, then you're not going to deploy to remove the feature toggles. No way. It's a recipe for disaster.
Okay, thank you so much.
Okay. So what about mobile apps? Distributed with a big delay. I can't answer that. I haven't thought ahead to that question. And I don't personally have enough experience with the life cycle of mobile apps and the Google Store and the App Store to know what it feels like as a mobile app developer. So I have to pass on that question because it's out of my expertise. XKCD said that Python made programming fun again. Do you agree? I do agree. I saw a great presentation that was given entirely inside of, it's not just the Python shell, but it's there's a kind of a program that lets you like see the output and the visualization of everything you do in Python. I can't remember what it was. And I saw this presentation about data visualization and data analytics, and the entire speaker experience was him typing up here on some Python thing, doing examples. And I was like, oh my God, that's why I programmed in the first place. This looks like so much fun. And I went out and read a book about Python like the next day and started learning Python myself because of it. So I totally agree. And can I click that link? Does that work? No, you all have to go and look at that XKCD, but it's totally worth it, I remember. Do you think the next logical step in bringing infrastructure to the developer is serverless? You know, that's a really interesting question, and I've seen a couple interesting things, especially Carlos's use of serverless in the CloudBees case running Jenkins as a serverless application. I was tempted to say no before the conference today, but after seeing what Carlos is doing and learning that you can deploy not only a Jenkins, but the current snapshot of Jenkins state into Kubernetes, and that every new serverless container that comes up can draw on the state through Kubernetes, then I think that way blows open the number of possibilities for serverless beyond what I was currently imagining. So I'm going to watch that space super closely. I think that it's probably too soon for a lot of cases, but if you have CPU stateless intensive things that you can express in something simple like Node.js, and you really work with the tools that are there, and you have a workflow there, you can version control that and build that and package that with git push, not uploading a zip file, then I think that, yeah, there's definitely a use case for serverless, and it stimulates the imagination in a beautiful way that I remember through different computing shifts, metaphor shifts, like when apps started being written, or when I first learned HTTP and how all that works, or when I first learned a database and all of these new possibilities started coming into my brain. Oh my God, I could do that, I could do that. Serverless definitely does that and tickles those things. Blockchain does as well. It really gets you thinking. So definitely worth watching, yes. Will ephemeral infrastructure instead of mutable infrastructure do? It kind of goes back to the question, if a tree falls in the woods and nobody's there to hear it, does it make a sound? So of course, from a philosophical point of view, that's one question with many answers. But I mean, from a physical point of view, the fact is there are sound waves. So from a physical point of view, an ephemeral infrastructure can still be hacked, can still be changed. It could still be that somebody logs in and does some crazy shit to it that you shouldn't do. It's probably less likely, but yeah, I think ephemeral immutable infrastructure would probably be the best. So I think it gets you some other way there. Any other questions?
Друзья, есть ли еще вопросы из зала? Если кто-то не успел задать на слайд, у нас есть возможность для последнего вопроса спикеров. Все, no more questions. Thank you very much. Друзья,
Thank you.
Официально.